Okay, welcome back to another session on population ecology. We're moving on to another part of this lecture now, onto populations through time. So the previous part of this lecture has been all about where populations or individuals within populations are situated within space, so kind of the spatial situation of the individuals, and now we're going to be looking at or tracking individuals through time instead. And the first part of this, we're going to be looking at population survivorship. So, essentially, not all individuals survive to maximum life expectancy. We can visualize this by following a single cohort of a population through time. And if you're not 100% confident in what a cohort means, essentially the definition of a cohort is a group of subjects who share a defining characteristic. And in this case, that defining characteristic is going to be kind of their birth time. So timing of birth here. So let's determine the survivorship of our red-rumped spots that we've been looking at throughout these lectures by tracking a cohort of the population that were all born in 2015. So that's what we mean by a cohort here, all individuals born at this time. Other examples of cohorts could be your classmates throughout school that were in the same year level as you. They're all in the same cohort as you. Alright, so let's take a look at a cohort life table here. We're looking at the red-rumped spot mortality throughout time. So it's the cohort that was born in 2015, and we're tracking this subset of the population, the 2015 born subset, throughout their entire lifespan to when no more of them are alive in 2025. So 2015, at age 0, 287 individuals were born. And then we just follow this through. 2 of them died, so the next year we're starting with just 285 individuals. 3 more died, that drops the population to 282. Or not the population, but this subset of the population. This cohort is dropping by the number of mortalities per year. And this tracks all the way through until no more of that cohort are left 10 years later. So, it is a lot easier if we try and display this visually on a graph instead. So we're going to look at, or we're going to track the population size based on the age of the individuals here. So population over age. Let's take a look at that. So this is our graph. So you can see that to begin with, it's a very low mortality rate. Only 2, 3, 5, 8, but you can see that it is increasing slowly, and this is what is creating this curve that we have going on here. And over that maximum lifespan of 10 years, so once we get to 10 years, all of the individuals are dead. Population size of 0 at 10 years of age. So essentially what we've got here is we're plotting this population size at each of the subsequent years. So 287, and then we've got 285 at 1 year, 282, and so on. So that is how we're plotting out this curve. Alright, so that is our red-rumped spot cohort survival chart. And we've got a survivorship curve here. So we've got the life cohort table and the survivorship curve that is produced from the values that we have in this table. So that's the red-rumped spot. We've got quite high survival to begin with, and then it drops off near the end. Let's look at a closely related species, the yellow-rumped spot, and we'll see how this one's cohort survival compares to the other species, the red-rumped spot. So here's our table this time round, and you can see that we've got quite a lot bigger of a cohort to start with. So we're still starting in the 2015 cohort, and we're tracking this subset of the population through time until there's none left. So we're starting with 4,354, but you can also see that quite a large number of these are actually dying in the first year since they were born. More than half of them do not even survive to 1 year of age. So we can already picture that this survivorship curve that we're going to draw shortly is going to look quite a bit different to the first one that we just made. So yeah, you can see that the mortality starts very high, but then it starts to drop off, and near the end of that maximum lifespan, we only have very few individuals still surviving. So let's take a look at what that looks like on a survivorship curve. So you can see that this time we've got a huge drop off to start with, and then it begins to plateau out as only a few individuals live all the way out to their maximum lifespan. So those are the two different species there, the yellow rump spot and the red rump spot. Now, if we wanted to show these lines both on the same graph here, so we wanted to show that red curve that went like this, that would be a little bit tricky because our population sizes were different. Our curve would end up down here somewhere, I think. There was very few individuals. Let's just double check. Okay, we started with 287. So if we attempted to plot the red rump spot on this, the curve would be down here and it would go all the way out to 10 years instead. So that doesn't really give us much to work with. So instead, what we want to do is change them to percentages rather than using the population numbers. We've converted it to percentage of population surviving. And this is what we're left with. So we've got the red rumped spot with that same curve that we produced earlier, and then the yellow rumped spot with that curve as well. And we're also looking at percentages of maximum lifespan as compared to just the age that we had before. And that's just to kind of standardize these curves so that they fit together on this graph. So yeah, these are survivorship curves. And this is only tracking a single cohort of the population and how they survive throughout their lifespan. All right, there is a third type though. So we've seen this curve here and this curve here. Let's pretend that we've got a third species that has kind of a straight line of mortality from birth through to maximum lifespan down the middle there. And these three different types of curves that we've got here, we give them three different names. So we've got a type 1 species, we've got a type 2 species, and a type 3 species. And the defining characteristics of these, for type 1 species, we've got a low mortality rate early in life. So you can see that there's not many of them dying to begin with. It's not until later on in life that mortality rate begins to pick up. Then we've got a type 2 species, where it is a somewhat constant mortality rate throughout the expected lifespan of these individuals or this species. And then we've got the type 3 species, which have a high death rate early in life. So most of the individuals don't actually survive that long, and it's only very few that get to live for a long time and continue surviving. So type 1, type 2, and type 3 species. All right, so that was population survivorship or cohort survivorship that we were looking at. We're now going to just take a quick look at population structure, which is slightly different to survivorship. So, just to recap, survivorship is a single way to look at a population's age demographics. And it only captures a subset of the population, i.e. a single cohort. This may not be ideal if we want to know about long-term health of the population as a whole. So, on the other hand, population structure looks at the entire population at a single moment in time, as compared to survivorship, which looks at a subset of the population throughout time. So there's a very subtle difference there, but it is quite critical just to understand what that difference is. Entire population at a single moment, subset of the population throughout a range of time. So yes, both have their own benefits, and it can be important to determine which of these you should be choosing to use. And this is just a bit of an example here of how we could display population structure. So remember, this is looking at how the entire population looks at a single moment in time. So we've got some examples here of human populations. And what we're looking at here, you can see we've got the legend in the middle here. The different colors are different kind of age brackets. So we've got 0 to 14 is the light blue, 15 to 44 is the yellow, and then 45 to 85 is pink. So you can see that the width here is the percentage of the population at these age brackets. So in this first one here, where we're looking at examples such as Kenya, Nigeria, and Saudi Arabia, you can see that the highest percentage of individuals are in this blue category, the youngest individuals. And you can see that we've got, it kind of just steps off like a pyramid upwards towards the maximum lifespan up at the top here. And also additionally, I'm just pointing out that the yellow coloration in the middle, that's indicating the kind of reproductive age of individuals. So the yellow part is reproductive, below that is young, and then elderly above that. And you can see that the wider the young are, so the wider this proportion of individuals that are being produced by the yellow age brackets here, the wider that is, the faster our growth is. So we've got rapid growth here because we've got a large amount of young being produced, and not many elderly individuals. You can see that if this is narrower, that means we've got slow growth. We've still got slightly more young being produced, but not as drastic as what we've got here. And then zero growth, it does look like we've got slightly wider of these ages 0 to 14, but the reason it would still be zero growth is perhaps because not all of these individuals actually will survive or choose to produce their own young when they get to that reproductive age. So this is still going to be a zero growth despite a high proportion of, or slightly higher proportion of young being produced. And then negative growth means that you've got not very many new offspring being produced at all. So yeah, just a quick introduction to that, but that's essentially all that I have for you today. Hopefully that gives you a good insight and start into this understanding of populations through time. This is just part of it. We're going to be moving on next to population growth. So this is population survivorship. Next is population growth. All right, that's all for now. I will see you in the next one.